So, fiction writers, what do we do about the speed of light? Science fiction, I'm talking about. I'm inspired to kind of talk a little bit about this because I was watching Bill Whittle's Stratosphere Lounge. I don't get to see it that often because it's kind of long. Not unlike my videos, but I did get to tune into the most recent one, and he was talking about basically his plans for basically a fictional universe he's creating to tell stories in, and what he plans to do to get around that. He plans to essentially use deep space travel, and as like a flotilla. Um, he explains narratively how that works, and he talks about they call them brown dwarfs, and basically the fact that recently we've discovered it seems like actually our neighborhood is a lot more populated than we think, which could lead to some cool stuff. Um, Basically, one of the things with sci-fi, see in Star Wars, we don't really have Star Wars doesn't really have this problem because Star Wars is fantasy. I mean, it's closer to a western than actually high sci-fi. Um, there's seemingly infinite number of planets. You can just jump to the speed of light. It doesn't matter. They call it hyperdrive. You're entering hyperspace, and sometimes they call it the jump to light speed because I think what they're referring to is essentially the relative speed you're moving. That causes problems on its own, but it's fantasy. So what are the common problems with basically faster than light travel? You break physics, you break causality, you break the rules in which the speed of information can travel. You break it. So does spooky action at a distance. So we know things do that, but we don't really understand the implications of that. You can't accelerate mass faster than the speed of light. So in terms of just like basically pointing a direction, jumping to the speed of light, you have a number of different problems. One is essentially you'll have to somehow transform or isolate within its own pocket, like a warp essentially, the matter you're trying to travel. And then you're also approaching the speed of light, and as you get closer and closer and closer, observation of your time gets slower and slower and slower. So like you're there instantly, but basically the speed in which the place you left is moving is to you would be accelerating. So you couldn't jump from Earth to planet at other planet at somewhere near the speed of light, and then have to come back and have any hope that the people you left, like you couldn't go on a mission and be like, hey, go get this from this planet, because by the time you come back to you, it might not be that long. The person who's getting the haul ass for either near the speed of light or at the speed of light, let's just pretend, it might not be that long to you, but to whatever you're trying to do on Earth, like, or wherever, the speed is the time's taken, like millennia, if not infinite time, because we don't really know like how would matter behave moving at the speed of light. We don't know, so that's an issue. One of the other big problems about that is that now you have something that is, and you could have a whole thing about this, but now you have something that's essentially a weapon. They used to have hyperspace in Star Wars, and then they did the holdover maneuver in in The Last Jedi, and that just broke everything. And that was like, I don't know why someone didn't just like somebody at Disney should have stepped in and said, you can't do this. You are breaking the entire franchise, which is already kind of teetering because it's fantasy. You're breaking the rules, because if you can accelerate an object at light speed or near light speed at instant, basically what we think of as warp speed, and you're not crossing through hyperspace, you're not crossing through a warp or dimension or a wormhole, you've essentially turned any object into a planet destroying. Basically, if you're moving at the speed of light or faster or even near the speed of light, and you can do that in an instant, you can blow up anything. If a small object were to hit Earth and it was moving near the speed of light, the damage would be unbelievable, let alone something that's like the size of a capital ship moving. Big problem. Big problem. So, that's one of the issues with when stuff's moving at the speed of light. When you think of just generically accelerating something, or even keeping something within its own wrap, you have a problem with causality, and you have a problem with just the fact that the logistics of actually moving that fast. So there's warp. That's the other option. Basically, you can do it a couple ways. Either you're generating your own jump into warp space and popping out wherever you're going, because you're not moving relative to you. You're not moving at the speed of light. You just happen to be basically taking a shortcut. But to the observer, you'd be moving faster than the speed of light. Or and so the ship itself is doing that, or you're using basically a jump point. Like I think Wing Commander uses jump points, and there's a lot of shows that use that. I like that because I feel like that would be creating a wormhole, or creating a way to jump from point A to point B in the universe is probably a large undertaking, not something an individual ship might be able to do. I don't know. I don't know where the science is going to go on that. But that's one solution, because you just say, oh, it's this big thing that does this thing and connects points in space. Don't think about it. What you've now done, though, is you've essentially created a problem, because you've sent information out from one point to the other in the universe faster than information is allowed to travel. You still have a causality problem. Are you actually jumping universes when you actually jump into warp? Is it mean that if you jump into warp, have you left is the universe you arrive in going to be the same universe as when you that you left? Maybe not. Maybe it's effectively the same. Maybe it's the causality is still there or something. But is it actually the same? I'm not sure. I don't know. I don't think physicists know. But then at the same time, if you think about the two-dimensional example they usually use, they use a piece of paper and they bend it and they say, look, you're going from here to here, and it's instant. It's effectively instantaneous, because you've essentially merged 2 points, and you've traveled faster into you've traveled further faster than the speed of light, effectively, than something in 2 dimensions, which is limited by the speed of information, speed of causality. You've now broken that, because you've traveled basically through the 3rd dimension. And the question is, us sitting in the 3rd or 5th dimension, depending how you look at it, are we? Can we even do that? And if we do that, what are the consequences? Because they say basically accelerating an object with any mass at all to the speed of light. They say basically that takes infinite energy. So that's not realistic. So you have to do some kind of loosey-goosey stuff with the physics in order to justify that. I don't know. I don't know what the solution to that is. I don't want to not tell deep space stories. I don't want to say, oh, well, I can't ever get into this because I can't remedy how it works. I mean, sometimes you just, whatever. Warp's the thing? Okay, cool. Whatever. Just write that off, because you have to get from point A to point B. But if you really, really stop and think about it, you're kind of... You're breaking a lot of rules here. Basically quantum communication, utilizing spooky action at a distance to basically have simultaneous communication. That's fast. Which is basically communication faster than you can send radio waves, which are moving at the speed of light from position to position. That would really be the only way to actually synchronize something in time. But the problem is now are you breaking causality, because you're moving that information, no matter what it is, faster than the speed of light? We know spooky action at a distance happens. We just don't understand 100% how it happens. We've been trying to work on quantum computing and just quantum in general, and are we going to discover something in the near future that's going to render our entire speculative sci-fi warp jumping obsolete? Because we might learn it's impossible to actually travel in a traditional way. Traditional, you know what I mean? In the sense of you're actually traveling from position to position faster than information can move. We may discover that's actually impossible. But there might be something else that replaces that, are you actually universe jumping? Is that actually what's going on? Where you're not actually you're just moving where you are. I mean, I imagine there's this problem, and this is one of the problems I have with warp drive. The way it's explained a lot is that you're saying you're bending space. Well, you can't actually be bending space because that would be like somebody who exists in 2 dimensions. So you fold that paper, right? That there's a 2-dimensional plane that exists there, and it doesn't matter which way you bend it and twist it because that 2-dimensional plane is the 2-dimensional plane because you're not thinking of the third dimension, right? And now you take that and you bend it, and now you say, okay, well, something that was 2-dimensional only existed 2-dimensionally. How would it do that? I don't know, right? It can't. Like think about that, right? Like it can't, can it? You know, like like if we're 3-dimensional and then there's 2-dimensional, how could we even recognize what if there was intelligent life in 2 dimensions and they were trying to figure out the same exact problem, right? They're trying to figure out how to jump, basically travel faster than the speed of information. We can do that, and it doesn't, we can do that relative to their plane of existence. And it's just commonplace because we're able to move in 3 dimensions. But, the idea of them ever breaking out of that or us breaking out now the other direction, it's the same problem. It's just that, now we're the ones trapped in a plane, essentially. We're the ones trapped within our own rules. How do you break out of that? I don't know. I don't know how to justify that. I don't know how I don't know how, as fiction sci-fi writers, we remedy that, because between causality and essentially energy, the relationship we know basically between energy, velocity, speed, and dimensional stuff that we know very little about. Rick and Morty are jumping from dimension to dimension, they're jumping from universe to universe, and doing all kinds of weird stuff, right? Yeah, but that's not serious. That's not serious sci-fi science because. If you were to take a ship and you wanted to go out to somewhere and come back and bring something from point A to point from point A to point B and then back to point A, and you're moving faster than the speed of information is allowed to travel, are you able to do that? Maybe you can do that, but it's not relative. But the universe around you, is that gonna follow the same rules? Probably not conventionally. I don't know. The causality problems alone are just mind blowing. I don't know how is instantaneous transmission of information possible? Because now you're moving faster than light, and I feel like if we're going to move faster than light, we're not going to be like 1.5 times light speed. I think it's just going to be instantaneous. It's going to be. I should say, relative to any observer anywhere in the universe, it should be an instantaneous transaction. Maybe that's the problem, is that you getting from point A to point B, it takes you God knows how many years, but to the observer it's instantaneous. At which point, you could only send a drone to go do that. And also, maybe that's just the kind of thing that you can't possibly do because you don't have an infinite amount of duration for any mass object you try to send in that way. It can't have infinite duration in order to be able to get to the other place instantaneously. Which, I don't know, maybe that's a crude explanation of basically the causality problem as you approach speed, as you try to accelerate to the speed of light anyway. I don't know. Is that going to stop us from, writing about jumping from system to system? No. But if you think about it too hard, your brain starts melting, and it certainly doesn't satisfy the people who are trying, high math, trying to work on these problems. I don't know. My solution is to say, screw that. And I like the idea of, there's a kind of a story universe where we're piecing together. And it's basically, the idea is essentially, it's everything within everything happens so much so far within our solar system, or within basically moving at relative speeds where the traveling is far, but you're not like doing anything like seriously warping time. And we have another problem too, is that uh, you know if you place an atomic clock in the basement of the world's tallest building, and then you place one on the roof of the world's tallest building, they don't line up. Earth's moving at a certain speed. We have a certain amount of time dilation just from our velocity, and there's nothing we can do about it. I don't know how that relates to Planck frames. How do you measure a Planck frame? Is a Planck frame going to be the same when you no matter where you observe it from? There's so many more questions we have to solve, or at the very least find a workaround to, in order to actually be like, okay, well, this is the realistic way we're going to do it. Because when somebody's got a ray gun, or they've got a blaster rifle, or they've got the AI that's super smart, you can kind of just, you can hand wave that, be like, whatever, they developed that. I can see how they got to that. Like, oh no thing could be that big, or could be that smart, or you couldn't build a machine that complex. And you can. It's basically like well, Bill Whittle said, it's like if you showed somebody in 1920 the skyline of Los Angeles. 1920 is when like electricity was just starting to kind of come everywhere. You would see they'd see all that, and they'd understand what happened. They would know basically what to do. It's basically like advanced technology, and you could light up everything. Like, they understand the what's going on. But if you were to show somebody from 200 years ago that, they would see that, and they wouldn't have a clue what the hell was happening. They'd be like, you can't do, what do you mean, like light in your hand, like from a thing, and you could talk to somebody? Like, what are you talking about? It just wasn't there. So in some ways it's like, oh yeah, I guess the limits are there are no limits. But with sci-fi, we kind of want to say, we at least want to kind of guess what's right. And it kind of sucks, because it's like, every time somebody tries to predict 15 years in the future, let alone a couple hundred years in the future, they're always wrong. They're always wrong. I mean, I can't imagine, like, in 500 years, when we're doing our space stuff, and somebody watches an old movie. They watch the first Aliens movie, and they go, oh my god, because we watch that now, and we're like, oh man, you see those tube TVs? Or like, oh man, that's not how we would do it. You kidding me, right? Like, just having a smartphone, like we that didn't exist. It wasn't really, I mean, there are some people, I think, who did predict essentially the micronization of electronics, but how many people predicted electronics, right? Is there going to be something that supersedes that, and that we don't understand at all right now, that might actually be completely revolutionary? But how can you predict that, to write that into a story? I don't know. So my solution is basically keep things closer, do rotating habitats, do terraformation. I love the idea of basically space stations, rotating habitats. No jumping. The solar system's big enough where I think you can tell a lot of really cool stories, and you're still out in the sticks. Guess what? If it takes a month to travel somewhere, I mean, that's the same as somebody writes an adventure in 1800 where the person sails across the ocean. It takes them 3 months to get there, and then they're in the big wilderness. There's like, if that guy's a British general or whatever, like he is the representation of the British Empire. Like, that's Bill was going on about that kind of stuff, and it's like, yeah, that's you're isolated, you're on your own. The original Star Trek series, Captain Kirk, he's on a 5-year operation, and he is the Federation. He's the ambassador to the Federation. There's no backup in that, and that's a sense of wonder. TNG didn't do that. They had a different approach to things. I'm not saying that's any better or any worse, but it's a different kind of problem. TNG basically broke the. They kind of said, well, to hell with the certain levels of the science fiction. Basically, we can't. If you can travel, if you can go somewhere, you have to be able to kind of go somewhere. So they kind of took warp and really ran with it. And I mean, I don't know. That's the thing, though. With Captain Kirk, yeah, it might be 5-year mission to him, but like, how much time passed on Earth by the time he gets back? I mean, that's the thing. Like, you could send somebody out on a mission and be like, hey, this is a generational ship, and it's going to be 100 years to you, and it's going to be 1,000 years to us because it's just how fast you're moving. And good luck. But then, 200 years from now, we send another ship that's got a better and different technology. And guess what? Those people who were supposed to be the first people, they're not even the first people to arrive at the destination they're trying to arrive at. Maybe that could be its own kind of interesting story. Basically, a colony ship goes out and they know, they're like, okay, well, it's going to be a generation of people living on the ship and we're going to be approaching this certain speed and we have to do these certain things, but we will get there. And then they get there and, they're like, okay, we're bringing things, we're starting civilization, and they get there, and there's a civilization that already exists, and it's like 4,000 years in the future, and they're like, oh yeah, we figured out a way around that, about 500 years after you left our time. So, sorry, I know you guys wanted to be the first. You're important. I mean, maybe that'd be like a really valuable thing because like, oh, they know this is going to arrive, and it's like it would be like a ship leaving for America in from England in like 14 something, and then we know they did that, and then we find out technology advances, and then we know they were scheduled to arrive our time in 2012 or 2020, and now we're going to be there and we're going to say hi, welcome. Sorry, sorry, your achievement isn't really an achievement. I mean, it kind of is. Congratulations, welcome. We got to vaccine you because we don't want you to get sick and die. There's like 1,000. It's weird. It's like what do you do to tell these stories? I mean, God, like if you've got orbits moving, if you've got rotational habitats moving at different orbits. That's gonna screw up the time dilation. I mean, the International Space Station has screwed up time dilation because of the velocity they're moving. What do you? I mean, if literally we have an object that is one solid piece of matter that has, the Earth has that, but we can build a skyscraper where the time is different at the top than it is at the bottom, even though it's minute. What does that mean? How do you do financial transactions? How do you do a financial transaction? It'll have to be crypto, but like the clocks, computers depend on clocks syncing up, and you can't do that in space. Maybe NASA found a way around that. I'm not sure. It's just it's a weird problem, and there's enough crazy stuff I think in the short term about like basically how to dominate our solar system and make it livable. That I don't feel the need to necessarily tell the deep space lore of things. I mean, that's actually one of the issues I have with Warhammer is that I find it really fascinating, but I find the entire size of the Warhammer for the 40K, the entire size of the universe, the time dilation problem. It makes me really think. It's like, well, are all these things actually happening simultaneously? Is that actually what's going on here? Is the Empire actually that big, or is it not that big, or is it something that they've discovered and they've found a way to make it infinite? Essentially, I don't know. What are we going to do about that? So minor thing, sci-fi stuff to talk about. I don't have a solution. I think the closest guy to have a solution is probably Isaac Arthur on. He's got a YouTube channel. I got to catch up. I used to watch his stuff constantly, but it's gotten longer, and I just haven't had time. He solves like a lot of fictional problems. Like if you're a sci-fi writer, binge his channel a little bit, and you'll, at the very least, you'll get an idea of what not to do, because you're like, oh well, this doesn't happen for this reason, or you'll say, oh well, I want this to be the case, so I have to make an excuse and I have to ignore something. Like you'll learn a little more than I'd say you're guaranteed to learn something watching his channel. I don't know anybody. I don't know anybody who doesn't have something to learn watching that. Particularly if you're a fiction writer, a sci-fi writer, you just like physics, and you just like this space exploration stuff, and you're wondering like where's stuff going in the future. What are we doing? That's the best channel, period. And I think what's crazy is that how it's even more fun to imagine how wrong is that going to be. 500 years from now, somebody's going to look back there and go, oh man, they thought we were going to do it that way. Well, we discovered this, right? I mean, who knows? Who knows? Future's crazy. So, let's not screw it up with communism. And we're on the cusp of something big, I think. So, we'll see what happens.